read from or write to data resources sequentially. Often with streams are used to read from or write to data sources sequentially, as I earlier said, often with improved efficiency and reduced memory usage. And we have different types of streams. We have several types of streams like readable streams, writable streams. We have the transform streams, and then streams can be piped together where the output of one stream becomes the input of another. This chaining mechanism allows you to efficiently process data without loading it all into memory at once. NodeJs streams are very powerful. They're powerful features that contribute to scalability and performance of applications, especially when dealing with large amounts of data. That's where streams comes in. And the first on our list, we have the readable streams. Readable streams are a type of streams that provide an interface for reading data from a source in chunks, but not all at once, in chunks. I mean, they provide this interface for reading data in chunks rather than reading the entire data at once. They are used for efficiently handling large data sets or continuous data streams, like reading files, receiving data from network sockets, or fetching data from APIs. NodeJS readable streams possess some characteristics like chunk reading, flow control, event-based. They are event-based, yes, piping. Like readable streams can be easily piped into writable streams or transform streams, creating a seamless pipeline for data processing. And they are event-based. Readable streams emit events as data becomes available for reading. Common events include the end data, and the error for handling stream errors. The flow control. Readable streams have built-in flow control mechanisms that help manage the pace at which data is read. This is useful when the data source produces data faster than it can be consumed. And chunk reading. The readable streams one at a time. This allows you to work with data as so without wasting much time, let's create an example of a readable stream and see how it works. This one. Just delete this one. So let's create a readable stream and then see how it works. First of all, we import our FS module. That's our file system module. And then we create a readable stream. Let's say comes readable stream is equal to FS that creates read stream, and then we pass it a file. This is data txt. Then we create our data txt. Let's paste some data in our data text. So back to our readable stream. Now we've created a readable stream. They want to listen to data. We want to capture the data that is being read from this stream. So what we do is we say readable on. So what kind of events? And they will pass in a callback chunk. What do you want to do with the chunk? We want to actually, let's say, we'll log let's just log the chunk. And then what next do you want to do? We want to actually say if we have finished reading the data, we'll attach another event here, which is the end. This indicates we'll finish reading our data. So we want to like indicate that we're done reading the data. So we'll say done reading data. And if there's any error, we want to handle the error as well. Error. Passing a callback. Grab the error from grab the incoming error, and we log into the console. Okay. So let's test this out. As you can see, we are reading these chunks. And after reading it, we have done reading data. And actually, what you can do here, you can say, let's say chunk dot length. Let's see the length of the chunk. 234 bytes. Okay, we can even say something like bytes. Let's say something like read. Something like this. Read 234 bytes. Let's make it look nicer. Okay, so we are reading 234 bytes of data. This is the data we have in here, actually. Is it up to 235? I'm not sure. This is just the length of the data we are reading. So we can actually do something like log chunk to string. You can see to string UTF-8. And we have our data on the console. So what's happening here is this data is not being read once. It's read in chunks, not at once. So that we don't have the problem of memory outage or something like that. We read our data in chunks, no matter how large it is. We read it in chunks and then we output it to the console. We don't have to wait. We don't have to wait for any kind of large amount of data to be read before we process it. Immediately we read a chunk, we process it, and we read another chunk. So that possibly an example of a readable stream. Of writable streams. Writable streams are a type of stream that provide an interface for writing data to a destination in chunks. Rather than writing the entire data all at once, they are used for efficiently handling large data sets, sending data to destination like files, network sockets, or like HTTP requests. So imagine you have a server and a client sends a request to your server, and you have to send back a large amount of data. You don't just send it once because your server will crash. You send it in chunks. That's basically how the server works. You don't use the read FS or read file or write file like that. You use streams to read and write files. So your file is being sent in chunks, not all at once. The writable streams also have some characteristics like chunk writing. Writable streams accept data in chunks, allowing you to write large amounts of data in manageable pieces. This can help optimize memory usage and performance. And also buffering. Writable streams may internally buffer data that before it's actually written to the destination. This buffering mechanism helps to improve efficiency by combining small chunks into larger writes. Writable streams emit events to indicate the state of the write operation. Common events include drain, when the internal buffer has been flushed and is ready for more data. Error, when an error occurs during writing. And then piping as well. Writable streams can be easily piped with readable streams or transform streams to create a data processing or pipeline. To work with writable streams in NodeJs, we generally create an instance of a writable stream. Then use methods like end or write to send data and write to send data and end to indicate the end of write. Basically, that's just how writable streams works. And without speaking too much English, let's jump into writing code so we can see how the writable streams. Oops, I'm always making this. So we see writable stream is equal to FL to create writable stream. Then we give it an output file .txt. And what we actually want to do is we want to write, say, writable stream write chunk. You see, we want to write this to our file. Let's copy that. Let's see. That's chunk. Let's say this chunk is equal to this. I want to write it to our file. So what we do next is, after writing it, we end a string. Calling the writable.end method signals that no more data will be written to the writable. The optional chunk and encoding arguments allow one final additional chunk of data to be written immediately before closing the string. So basically, when this method is signaled, it's called, it signals to the writable that there's not more data to be written. Okay, so if we are done writing our data, we want to be notified. Finish writable. On finish, the finish event, take a callback that will notify us here that we are done writing. Done writing. And if there's any error, we want to also handle errors. Error. Take a callback, pass the error to the callback. Then we log the error to the console, like an error occurred. Error. Like this. Basically, this is how to work with writable streams. And let's see what happens if we try to paste our file. Sorry. Right. Done writing. And here we can see our output file. And here is our data. And this data is not written at once. It is being written in chunks, not at once. So that makes writable streams wonderful to work with. Basically, that's how writable streams work. And another example about writable streams, you can actually, let's say we have a server that is serving content to clients. Basically, a server that is serving content. It's okay. Come down here. Then set up our server. So equal to create server. Passing our callback. And then we set our header. $200 indicating success. Then content type. Content type is basically text/plain. Text/plain. And followed by press.write. Want to send back a chunk of data to the client. We can simply say hello. Then we send another chunk. Hello, client. So the client made a request to our server and we are sending back data in chunks. Then after sending it, we end the writable stream. Then we wire up our server. We see server.listen. Basically for 3000 with a callback function that tells us our server is running. Server is up and running like this. Then Let's start up our server. Okay. Server is up and running. Then let's see if it's working. Is saying wrong version number. Oops, I'm using HTTPS instead of HTTP. So that's what's causing the error. Now it's working. It's not secured, it's just hypertext transfer protocol, but not secured. Okay, so now we have hello client, but this data is being sent in chunks, not all at once. So that's how efficient. Okay. I can see two people raising their hands, but I don't actually know who they are. Please proceed.
Good day, sir.
Yeah, good evening.
What does the right head do?
Okay, the writer is simply sending the 200 stands for success. That means your request is successfully processed and you have your response, and the content type, the response you have is text slash, there is just normal text, not any HTML or any other content. The content you received is text, so you know how to process it.
Okay, so it's like res does status, right?
Yes, yes.
Okay.
Raise a status code. If you want to handle it on the client, you simply say raise a status code, which is 200, and then the content type, you indicate in the client that the data you are requesting for is text and place. So your let me say your client will know what to handle, basically.
Okay.
Yes,
I get it now.
yes, you are sending back the status code of 200 and you are sending back the content of text, not any other content.
Okay.
Yeah,
Thank you, sir.
welcome. Okay,
Okay. Hello,
who's
can
the
you hear
next
me?
person? Yeah, I can hear you.
Okay, I have two questions. The first one is um this right head or this writable stream,
Yeah,
when we have a large data,
yeah.
does it work like a synchronous process? Because I know we are
Yes,
not using synchronous. Huh?
yes, it works asynchronously.
Okay.
Okay, let me try to clarify things here because it's like we're confused about. Okay, go ahead. You said you have two questions. Go
Yeah.
ahead and
So
ask.
the second one is, how about when we want to um maybe add like maybe audio files that are large or video files that are large? Are you still
That is
going
the
to use the
main
same process?
that is the main reason for streams, for streaming videos and audios and large, because they send data in chunks. They send it little by little. If you notice, if you are streaming on YouTube or any other app, you see that before there's an indicator. So before the real red indicator that is indicating the level of your, let me say, the progress of your video, there's another gray indicator indicating, beneath that red one, there's a little bit ahead of the red one. So that is it's actually sending back data in chunks because the data is large and cannot be sent once. Data is being sent in chunks.
Okay. Please can you come again because I don't understand.
Okay, you stream videos on YouTube, right?
Yes.
Okay, so anytime you want to stream a video on YouTube, notice the indicator. The main indicator bar is black. Then the one indicating the progress of your video is red. So there's another indicator that is a kind of gray or something like that. That is way ahead of that main indicator that's indicating the progress of your video.
Okay.
So
Yes, that's true.
if your network is down, that gray indicator will be at the same level with that red indicator, and the video will stop playing. It will start loading. That means
Okay.
your network is down and the data cannot be sent. But if your network is up and running, that gray indicator is ahead of that red one, meaning the data is sent in chunks. It's sending back
Okay.
data in chunks. You understand?
Yes, yes, I understand now. Thanks.
Yeah. Okay. So let's say you have you want to write data to this file. We actually want to write data to our file. Output, is it output? I made a typo error. Let's say output of txt. This is an asynchronous operation. So we take in the error, and if there is any error, we log it to the console. Okay. Let's run this and see what happens. File.
I think after that error, sorry, we'll put CB like callback. It is required.
After what?
After the error parameter on line
Yeah.
28,
Yeah.
there will need to be a CB, a callback.
Okay, you mean like callback,
Yes.
basically? Okay, let's see. No, that is not why it's complaining. CB has invalid type, try and error. CB type, okay. So we have here data. But then why are we okay?
Sorry. That data, I think that data is not a function.
But this simply writing file, not reading file. We are writing to FS or write. Okay, let's just use streams here.
Okay.
Earlier we had create write stream. Yes, write stream. And we basically want to write the stream to and want to also handle errors. Let's use this because the callback, we are writing data and it's not supposed to be a callback there. Then we move our function up a bit, and then we'll drop it here. What file am I operating? Is it the right? Okay. Let's uncomment this. On writing, but we have nothing in our actually. know what's happening. Oops. And what's happening? My editor actually crashed. Okay.
Maybe it's because of that loop that you made.
Yeah. I simply, yes.
Maybe you should just change to like 1,000. And that loop is like 1 million.
Yeah, it's 1 million. Actually, what I wanted to do. Maybe it's too much. One sneak configuring again. Okay. Do you have anything? Okay. We have data here now. Maybe the loop, that was just too much. Okay, so now let's see if you can read this data. FS, let's read. Then let's say we want to read the out. Is it output?
Output 5.
Yeah, error the data. If any errors, we want to actually log the errors on the console. If no errors, we want to
No, you are
log
missing that error is
error. Okay, sorry. If no errors, we want to log the data. Okay, so let's test this out and see. Can you see? We have more. This is 237,950 more chunks. Okay, let's make it to string. So we don't read it in chunks. And see what's happening. The data is being read once, but this is an asynchronous operation. So it's as if it's reading in chunks, but it's being read once, just once. So in order to like make this more efficient, we use streams instead of using the files and the read file directly. We simply use streams to make it more efficient. We don't want to waste memory or something like that. And that makes working with streams more. When we get to building web servers, you see how important streams are and how they work, like how they read or write data in chunks. Okay. So what else do we have on our list? The piping. So the pipe function in the JStream is a method that simplifies the process of connecting streams together to create a data processing pipeline. It allows you to take the output from one stream and direct it as the input to another stream. So these streams using pipe functions enables efficient or continuous data streams. You call the pipe function on a readable stream, passing in the writable stream you want to send to data. You want to send the data to, or you pipe function. The pipe function takes care of managing the data flow between the two streams. It listens to the data event on the readable stream and then automatically writes the data chunk to the writable stream. So let's see how we can work with the pipe. Let's see pipe, yes. Then we require the FS. FS to create writable string, and the writable string is our output file. Let's say output txt, and then we create the readable string. Readable string. We create readable input. Take our input file. Input txt. Or let's say data. So what we want to do is we want to actually read data from our input file, then pipe it to the output file. So what we're going to do is we'll see readable stream pipe writable stream. They will simply see readable stream. Then we listen to the end event. If you are done reading the file and writing it to our output file, we should simply log done reading on the console. And if there's any error, so simply log it to the console. Log the error to the console. So yeah, so let's test our pipe and see how it works. Done reading. And then here's our output file. Good. Let's copy this. Okay. Dump it here in our input file. And write it again. Done reading. And if you open our output file, you see the content here. And that's cool. That is basically how to work with pipe. Okay. That's basically how to work with the pipe functions. NodeJs transform stream. Before we look at transform streams, let's look at Joshua, go ahead.
Okay, does it mean that the piping it reads from an input file and then writes like
Yes.
Okay.
Yes. As you can see, it's reading from the input file, then it's writing it, it's piping it to the writable stream. Instead of you to say, okay, readable stream, you read it, then you write it. You don't have to go through the manual process. You just say pipe. So you should take in the data and then just pipe it to this file. Okay, let's say we don't want to actually write it to the output file. All we want to do is to log it to the console. Using process of std out. Yes, something like this. As you can see it, we've seen it on our screen here. It's returning the data to us. We are piping the data to the console, not any file. Something like this. As you can see, the data is, we have the data on our console. So we read the data from the input file, then we pipe it to the console so we can see it. Here is it. That's basically what the pipe does.
Okay.
It's like you don't like seeing clear screens. So all these lines here, I think you are seeing my screen, right? The person is
Yes.
learning how to draw. Maybe you want to use this class and learn Figma. We're not doing Figma here. Okay, any questions?
Yes, I have a question.
Okay, go ahead.
Sorry, this pipe of 18, is the only file that we do streaming for? Like, I mean, this NodeJs streaming, this streaming capability, is it only for files?
No, not files, any kind of data. But you know, everything, basically everything we're working with is actually files, because what servers do is they read, if you send data, they read it and then save it somewhere. All your pictures, your videos, they are basically binary, they are basically binaries. You understand?
Yes, sir.
So what servers do is they read your data and then save it somewhere. So you must read data from somewhere and write data from somewhere, either a file or anywhere at all. Anywhere the file, the data is coming from.
Okay. So, like, sorry, apart from, sorry to cut you, sir.
Yeah.
Okay, is there anyhow without the file? Let's say you want to make a readable stream and you just want to stream a string of text without using this FS class, this file system class.
Okay. You can do something like this. Like this, right? You can import writable or write stream or anything here, or the stream this. Understand what you're asking, like this. Like this, right? Then you have your stream class, like this.
Yeah.
Sure.
So sorry to have on that one. Don't be annoyed. About this stream class, how can they use it to also write and to also make a stream of data, like a writable stream and a readable stream? I think I've seen it somewhere.
Yes, sure, you've seen it somewhere. Okay, let's take an example of this. Okay, we have the readable streams, the duplex streams, and then without using the FS module, you can also use the stream class. But then inside the stream class, let's see what we've got. Can you see the readable? We have the readable and the writable. But these are actually classes that you can extend. These are classes that you can extend. If actually you want to have, okay, let's see, you want to create, let me comment this out. And then require the stream, the require stream. Then we have our readable class. Then we want to have something like, let's say readable equal to new readable. Then This is actually an object. And this will take read size. This is a basic example. Then we have this dot push. Our example, our initial example, hello. And then this dot push. Hello, readable. Readable, yeah, like this. Hello, readable. And then the next thing is we listen to a null event. Once you push in null, it indicates that there's no more data to be written. So the stream will terminate. Okay, so we're actually done with our readable class and instance. This is the readable instance created on this object, the readable object. So what we want to do is we want to listen to events now. So readable data, the data event that we listen to chunk. I mean, we accept chunk as an argument, then we log chunk to string. No, just chunk. We log chunk. Then we listen to another event. And when we're done reading the data, we want to log done reading. Okay, let's see how this works. Posting the pipe. Can you see this? Done reading. We are reading the data in chunks. We have the first chunk, we have the second chunk. This is the first chunk, which is hello. If you check capital H, in the ASCII characters, it's 48, right?
Yes.
And the capital R in ASCII is 52.
Yes.
And then 65, we have E. E is 65. We have 65 and 65. And as you can see, we have chunks.
Okay. So if we want to make our own stream now, we have to extend the readable stream.
Yes.
Okay. Thank you very much.
And if you want to read it, we've converted it to a string. Chunk dot to string here. Hello, readable. Don't read it. And that's it. And who else? You can see two people raising their hands. Yeah, you can go ahead if you have any questions.
Okay, thank you, sir. The question I want to ask that if I have a two image and
Yeah.
I use stream, I do restream to read the first image. You know, if I read the image, it will give me the byte, all this byte code,
Yeah.
the Unicode. So can I use the Unicode to compare two images? Maybe if the image is the same or not.
Okay. You mean, okay, like this buffer is returning chunks now. You want to convert it to an image.
What I actually means that maybe instead of putting output.txt, maybe I put the name of my image .jpg. And what I'm asking is that, am I going to get the same all this Unicode, this ASCII code? If I get the ASCII code and I read another image,
No, in
so can
images,
I use
images, you do something, you require the sharp module. The sharp module. It's not an inbuilt module, but I just want to show you an example. So when you read your buffer, if the chunks in your buffer, if what you are reading it's an image. What you do is you do sharp. Let's say the data you're reading, let's say it's buffer. Let's say const buffer is equal to the data you're reading. We have 67, 44, and all of that, your buffer. So if you want to convert it, you say sharp, and then you take in your buffer, the data you're reading. Then you call to file. Which file do you want to convert it to? Let's say you want to convert, you want to give it a name. Let's say you want to give it image.jpg with an error, callback function error info. Error info. If there's error, if any errors, you log the error to the console. If no, if no errors, you log your info. Or you log your image. Let's just change this to image so that it's be clear to you. So you can make a little bit of research on the sharp package. You can make a research on the sharp package. Yeah.
Okay, thank you, sir. Although I've already
Yeah,
made use of it, but I just use it to do resizing
Oh,
of image.
okay. So you can also use it like this. I hope that's clear.
Yes, thank you, sir.
Okay. So we're talking about what we're talking about actually. We're talking about is it the duplex streams or transform streams? I think duplex streams. Okay. So I was coming to what who asked the question actually. But we're going to treat we're going to import the duplex from the stream right now, so you know how this can be used. So the duplex streams are a type of stream that can be both readable and writable. They allow for bidirectional communication, meaning you can both read from and write to them simultaneously. Duplex streams are particularly useful for scenarios where data needs to be processed in both directions, such as with network sockets or network sockets, yes, where data need to be processed in both directions at the same time or simultaneously. The characteristics of a duplex stream: we have two-way communication. Duplex combine the functionality of both readable and writable streams. This means you can read data from the stream while also writing data to it. Then it's event-driven, similar to readable and writable stream. Duplex streams emit events like data, end, error, and then drain to notify you of changes in the stream state. Then buffering. Duplex streams might buffer data before it's actually written or read. As you all know, it helps. It actually helps to optimize data processing and performance. And then piping, just like any other stream type, duplex streams can be easily piped with other streams to create complex data processing pipelines. And let's quickly jump into working with. Okay, let's see duplex. Yes. Now, let's see. Duplex equal to require string. And now you see, or let's see, comes my, let's say my string equal to new duplex is your read size. See this push. let's do something like okay, size bytes of data, and it should end with a new line. Size bytes of data. And okay, let's specify a condition that if the size is greater than or equal to 30, let's just or 30 or 20. Let's make it a 20. Let's push in a null to indicate that there's no more data to be written and we want to actually end our duplex string. Then after that, I want to write, because this is a duplex string that I can read and write. The chunk will just read the encoding. Oops, outside. Chunk, the encoding, and call back. We want to log the chunk on the console, then invoke our callback. Okay. So in this case, let's see my string.pipe. Oh, my string.pipe process.stdout. Yes. Process.stdout. Okay. Now I want to write, let's see, my string dot write hello, and my string dot write hello string, another chunk. We are sending in 2 chunks here. Then we want to actually end the string. And so let's see what we've got. Okay, duplex. As you can see, what we're doing here is we're reading data and then piping it to the console. That is stdout. We're actually reading in data, which is we're reading these 2 chunks, hello and string, then piping it to the console, which is the stdout. Here, after reading it and then logging it to the console, then we log 16,384 bytes of data. Can you see that? And you can actually make this a string. Hello string, 16,384 bytes of data. So as you can see, our duplex string, we can also read and write data at once, and that's beautiful. So the NodeJs transform streams. The NodeJs transform streams are types of duplex streams that allow you to modify or transform data as it passes through the stream. They take input data, process it in some way, and produce modified output. Yes, and then the transform streams are particularly useful for tasks like manipulation, yes, compression, like you want to zip your file, you want to compress your file, then encryption, or any case or any scenario where data needs to be modified in transit. You understand that kind of thing? In transit, mean when you're reading your data and you want to compress it before writing. That's what it means by in transit. So you're reading data and you want to perform some kind of action on it before processing it. I mean, sending it to the output source. You simply use duplex streams. The characteristics of a duplex streams have duplex functionality. That is, the transform streams. Transform streams are duplex streams, meaning they can be both readable and writable. They take in data, transform it, and then produce modified data. They're event-driven. The data transformation, the main purpose of transform streams is to transform the data as it flows through. There's no need to read it first, transform it, then write it. As it flows through, as it's written it is transforming it, and then writing it with output or storing it where it needs to be stored. Okay, let's see an example of a transform stream. Here we have transform. You will come down here and see, let's see, I want to transform data to uppercase, because uppercase is equal to new transform that takes in a transform, the chunk you want to transform, the encoding, and the callback. Then say const uppercase is equal to, we want to actually, our chunk that we are reading, we want to first of all convert it to a string. String is a function, so we call it, then we convert it to uppercase. Uppercase. Then you know as it works. If you want to write, you push it. You push in the data. These are push uppercase. And then you invoke your callback. Okay, now let's use another method here. Let's say process at std in the pipe uppercase, right? That's our data. The pipe uppercase. Then we want to pipe it. The pipe process .std out. Okay, let's see how this works. Let's I think we now push in now. What's happening? Okay, to uppercase. To uppercase, yeah. What's happening? To error events. Okay, string dot push end of file. Okay, we're actually pushing in now. It's not pushing now. Let's see. Some data is being written in uppercase. Can you see this? We're actually accepting data from the command line, that is the std. Then we are piping it as we're converting it to uppercase. Then we're still piping it to the std out. We receive the data, we convert it to uppercase, then we send it out at the same time. That makes transforms streams very powerful. That's great. That's great. Oh, I wanted to clear my console and oh, it's piping. Oh, that's sweet. Okay. So that's basically about streams. You know, in review, we've learned about streams, how we can efficiently work with data without writing all at once. We write data in chunks, and that's basically how helpful and useful streams are. And I think we are done with streams for today. Okay, so we've discussed about readable streams, writable streams, piping, transform streams, and even the duplex streams, in how useful they are, how you can just read data, process it, and then send it out at once without having to write it first, then wait, then after writing, then you process it before sending it out. And this is actually sweet. Maybe you have a streaming service that you actually, people save videos in high quality. Their videos are high quality. Then you compress it to low quality, save it in your database, and then if they request for that video, you have to convert it to their initial quality, the quality they sent in the video before sending it to them. I use transform streams, where you just retrieve it from your database, you quickly convert it, then you send it back. And that's basically what YouTube does, because the videos on YouTube are of high quality. So when you upload videos, you compress it, keep it in your database, and when someone requests for the video, or like someone wants to watch it, they quickly fetch the video from the database and convert it to the high quality video, then send it to users to watch and enjoy. Okay, so that is basically about streams. Okay, so next on our list we have events. We have listening for managing event listeners. Basically, what we're going to be doing about events is, for today, we're not going to be writing any code. About events, and then we will peacefully end the class. Then our next class, we'll be talking about events, only events, emitting events, listening for events, capturing event data, handling error events, managing event listeners, because it will take much of our time. So I want us to use a single class and then discuss about events and then go in depth, because when building web servers, those are the most important part, events, because you need to listen to events. You send in requests, then you write out responses. All those are events. So we need to know in depth what events are. So basically, we're just going to be doing an introduction about events for today, and then in our next class we go in depth on events. So event emiters are objects in NodeJs that trigger an event by sending a message to signal that an action was completed. JavaScript developers can write code that listens to events from an event emitter, allowing them to execute functions every time those events are triggered. In this context, events are composed of an identifying stream and any data that needs to be processed to the listeners. Typically in Node.js, when we want to have an action occur upon completion of another action, we use we use asynchronous programming. But then when you nest too many callbacks, it leads to callback hell. So, and these techniques, they're kind of they call it coupling. They are tightly coupled, that if you want to modify or change something in your code, it becomes a kind of difficult, or you want to test your functions individually, it becomes somehow difficult. So that's where events comes in. So event emitters provide a different way to structure the relationship. That is the pub/sub pattern. Another pattern in Node.js, that is in the observable pattern. We know what we didn't talk about it. I told you to go and research about it. You know about the pub/sub. There is the publish and the subscribe pattern. It's a kind of a software architecture pattern that a publisher, that is the event emitter, sends a message. That is, the message is an event, and a subscriber receives the event and performs an action. The power of this pattern is that the publisher does not need to know about the subscribers. Yes, it doesn't need to know about it. The publisher publishes a message, and it's up to the subscriber to react to it in their respective ways. So if you want to change the behavior of our application, we could adjust how the subscriber reacts to the event without having to change the publisher. Can you see how sweet that is? We have different things on our list that we'll be talking about in our next class. We have the emitting event, listening for events, capturing events data, handling error events, and managing event listeners. So before our next class, I urge you to all go and make research about all these things, because we'll actually build a mini project on this. After discussing, I'll try to understand it in depth. Actually, there is I don't know what is, I've forgotten what to call it, but it's a session for students on Saturday. So if you have any problem, you join the meeting by 7 p.m. on Saturday. But before that, maybe I will request from my boss a time that I can have a special session with you, and then we treat anything that's confusing you. Like concerning our previous tasks and anything that's confusing you, try to discuss it. There's no kind of a lecture, it's a kind of discussion. So we discuss it, and then you tell me where you're confused, where you don't understand, so we can treat it together. So for today, is there any questions? Or are there any questions? Bad English, pardon me. Do you have any questions? Okay.
I really don't have questions. I just have to go over the recording again, because it's some of these concepts are totally new to me.
Yes, they are new to you. They are quite Node.js team, and they are server side. So maybe you've been dealing with JavaScript on the client side without touching the server side. Are you a React kind of person?
No, I've not done React yet.
Okay, but you've been working with Node.js.
Yes, just
you know, the reason why you don't know about this, Express.js handles all of this behind the scene. So you don't know what's happening. All you need to know is to use Express. But when you know about all this, you use Express efficiently, use it very well, and even like implement some of the things that are not built into Express, and that will make your code more robust.
Okay.
Yeah, sure.
Thank you.
Yeah. So in absence of any questions, we end today's lectures, and in our next class, we focus on events. We discuss events in depth and build a project. And our next week, we jump into building servers using plain Node.js, just Node.js without Express.js. Yeah, Moses, go on.
So, thank you for the class.
Yeah.
The last class we had, the video has not been dropped on YouTube.
Okay. Okay,
So
I will.
we are still waiting for it, sir.
Okay, no problem. It will be dropped soon. Don't worry.
Okay. Thank you, sir.
Yeah.
Hello, sir.
Okay.
Sorry. You said next week we're going to build a project. I not get that.
Yeah, I can hear you.
You said next week we're going to build a project. Like you said, cyber project. I not hear that.
No. I mean on streams. I mean, in our next class, we create streams and build a mini project. Then from next week, our classes, we start building servers, which we use Node.js without Express, plain Node.js.
Okay, sir.
Yeah. So thank you all, and I will see you in our next class.
So.
Okay, thank you, sir.